Alright, I'm going to shoot through our review guide here. Hopefully this will help some of you because you'll get a little bit of an explanation for some of the answers. Question number 1 says compare y equals 2x squared plus 6x minus 3 halves to the parent function. Our parent function for quadratics is y equals x squared. In this case, this new parabola, this child parabola, has a 2 for an a value, and a controls whether it's going to be wide or narrow. If the a value is bigger than 1, or if the a value is less than -1, then you're going to end up with a very narrow graph compared to the parent. So in this case we've got a 2. 2 is clearly bigger than 1, so that means it's going to be narrow. And because it's a positive 2, it's going to open upward, so it'll look like this parabola, like that. Okay, so I want an answer that says, hey, you open up and you're narrow. So opens up and narrow. That looks like D to me. Question number 2, what is the equation for the axis of symmetry of this? The axis of symmetry, there's 2 ways we can find it now. One is to complete the square on it. The other is to remember a formula. The formula is the easy way to go. It's negative b over 2a. It's not too bad to remember because that's also part of the quadratic formula. So we go negative b, so negative 6. Remember, b is right next to the x there. Over 2 times a, which is 3. So negative 6 over 6, x is negative 1. That's all we have to do. There's lots of alternatives for this thing. You could also throw it into your calculator and take a look. Of course, that would be pretty weak because we don't need a calculator to do negative b over 2a. Number 3, what are the coordinates of the vertex? The first thing I would notice is this equation is the same as the equation we just worked with. That means we already know, since we know the axis of symmetry, we know the x-coordinate of the vertex. The vertex is going to have to go through that same x value. To find the y value that goes with -1, I just have to plug -1 in for x. And so I go 3 times -1 squared plus 6 times -1 minus 7. -1 squared is 1, so that's a 3 minus 6 minus 7. That's -3 minus 7. I'm getting a -10 for that. So the x value is -1, and that -1 gives a y value of -10, which is answer B. Let's go on to question number 4. Let's see here. Question 4. Let's see if we can blow this up so you can see it right. Try to do 3 questions per slide if we can. There we go. Alright, question 4. What is the y-intercept of, I'm going to be kind of careful here, I don't like the way it's formatted. What is the y-intercept of y equals 3x squared plus 6x plus, minus 7. There's a minus sign that's floating way over there. Minus 7. The thing you have to know about y-intercepts is y-intercepts always have an x value of 0. So if I want to find the ordered pair, I plug 0 in for my x's. Makes the first term 0. 6 times 0 is 0. Y has to be -7 over here. So 0, -7. Let's see here, that looks like C. Let's erase some of this stuff. Next question is, which graph at the right has no zeros? Remember, zeros are where you cross or touch the x-axis. So this one has zeros there. This graph has zeros. D has zeros. C right here, it never touches the x-axis. And finally, 6 on this page, which of the following is a step in solving x squared plus 5x plus 6 by the factoring method? Well, let's just factor it, and then we will compare it to the answers. To get 6, I could either use 2 and 3 or 1 and 5. Sorry, or 1 and 6. But they have to add up to 5. Well, 1 and 6 have a difference of 5, but 2 and 3 add to 5. So I'm going to add those two, and that factors or multiplies back to give us this x squared plus 5x plus 6. Okay. Now if you look over here, that doesn't really correspond to any of the answers, because the next step would be set each factor equal to 0. So I want one of these answers. X plus 3 equals 0, or x plus 2 equals 0. That's answer A. And the next one, let's see if we've got a few more of these on this page. And select all, cut, let's see here, select, let's see if we can make this nice and big for you guys to see it all. I think we're on question 7 is all. Alright, question 7, the solutions to this equation right there. Notice in this equation, x plus 16 squared equals 25. We got a perfect square on the left-hand side. So I would solve this by square rooting both sides. X plus 16 equals, when you square root, you get plus or minus. So x is negative 16 plus or minus 5. Now you actually have to go through and figure these two answers out. The answers are negative 16 plus 5 and negative 16 minus 5. So this one gives me a negative 11, and this one gives me a negative 21. Okay, and that is answer D. On to problem 8, what value goes into the blank to complete the square? I check to make sure my A value is 1, A equals 1, so I take negative 8, divide it by 2, and square it. That's negative 4 squared, which is 16. Easy enough. That number you add to complete the square is always positive. Ooh, a discriminant question. Remember, discriminant is equal to just the value of b squared minus 4ac, so it's negative 8 squared minus 4 times a times c. 64. I got two negatives here, which means it's going to be an addition problem, plus 48. 2 times 4 is 8, and 8 times 6 is 48. And so I add those two together. 8 and 4 is 12, carry 1. I'm getting 112. So my discriminant is 112. That means this quadratic equation will have two real solutions if I were to solve it. Question 10. How many real zeros does the equation have if its discriminant is negative 9? If discriminant is negative, that means you're getting imaginary solutions. So this thing doesn't have any real zeros. Let's see here. That was problem number 10. So let's go to the next one here. See if I can get it on there for you. Alright, problem number 11. Problem 11, I've rewritten these answers on the test. You'll have a problem very similar to this. Notice how they've left it as like negative 4 plus or minus square root of negative 32. If we have the square root of a negative, I've simplified your solution. So we'll go ahead and work this down to have an I for an answer. So here's the original problem. I should say we'll have an I in our answers if our radical or radicand, the discriminant rather, is negative. If I was solving this quadratic equation, the first thing you want to do is see if you can reduce it. In this case, everybody's divisible by 2. The next thing I would do is see if I could factor it. And it looks very factorable because I've got a 2 in the middle and that 3, but if I start doing this, I realize I have to have negative 3 to get that negative 2, and that would make this 1 positive, but 1 times negative 3 doesn't give me the plus 3. So this thing is not factorable. Okay, it's a prime polynomial. So given my choices, I generally go with the quadratic formula. Just for review, I think I'll use complete the square method. To complete the square, I take the 3 to the other side. My a value is 1, so I take 2, the b value, divide it by 2, and square it. So I get x squared minus 2x, and I'm going to add that 1 here, and I add 1 to the other side. There's my perfect square now. it will be factorable, and the right side is 2. Now that I have my perfect square on the left, I can square root it. X minus 1 equals plus or minus root negative 2. And so x equals 1 plus or minus the square root of a negative is I root 2. Okay? And that's how I would have the answer on the test if you have imaginary solutions. For whatever reason, that does not match any of these answers. And you can tell why. It's got 32s in there, and it's got 48s in there. And 32s and 48s can be broken down. I'm guessing, I'm not guessing, I'm looking at it, and I believe it's going to be answer B. So I'm going to show you how B gives you that same solution. Again, you wouldn't have to do this on the test, but it is good practice for you to see. So this, if I was solving it on the test, that would be one of my choices, A, B, C, or D. Here's the answer B that they have here. Okay, if that was my solution from the quadratic formula, I'd first take an I out, and then I'd factor 32 as 16 times 2. Okay, and I'd factor it that way because 16 is a perfect square, so a 4 comes out. And now everybody's divisible by 4, so 4 divided by 4 is 1. 4 divided by 4 is 1. So we can see answer B is the answer that coincides with the answer I got when I solved it. Okay, let's get rid of a bunch of that stuff if we can. Let's go on to question 12. Question 12, we just saw how to simplify a radical. And question 12 is asking us to do exactly that. Simplify this answer, negative 8 plus or minus root 16 over 2. That's negative 8 plus or minus 4 over 2. It's negative 8 plus 4 divided by 2, and negative 8 minus 4 divided by 2. So this one gives me negative 4 over 2, which is negative 2. This one gives me negative 12 over 2, which is negative 6. So I want negative 2 and negative 6. Answer A. Number 13. Given the height of a ball, and they give us an equation for it, how long will it be in the air? Kim solved it and found these two zeros. Assuming your calculations are correct, which should be the answer? Think about this. This equation here is finding out, it gives you height as a function of time. That's the t in the equation. When she solves this, she finds out time is either a negative 0.56 or time is a positive. And so clearly, since time doesn't travel backwards, we want to use the positive time. Okay, so that 3.56 would be the correct answer for that. Let's see here. We got two more problems. 14 and 17. Let's take a look at these really quick. 14 is a solve problem. Notice right away by staring at the answers there, these are nice integer answers. What that tells us is this thing better be factorable. I would divide out my 3 first, and then I'd try and factor it. X and X, 1 and 3, this time positive 3, negative 1. Okay, you can see outside is 3x, inside is negative 1x. They add up to the positive 2, and the negative 1 times 3 gives you negative 3. Don't forget, we have to set those factors equal to 0 to solve it, so x is either 1 or x is negative 3. Oops, not that one. 1 and negative 3, which is answer D. And finally, our last one on the review guide is find the vertex. And they give it to you in vertex form. And so remember, this is y equals a times x minus h squared plus k. We can see the h is 4, and our vertex is at h, and the k is 8. h, k. So 4, 8. And that's it for the review guide. Don't forget, there's a lot of stuff that's not on this review guide. This is just a sample. If you can do this without looking at your notes and reviewing anything, you can just go at it and attack it, then you're ready for the test. There are also 4 other questions on the test that are not on this review guide, and those 4 questions are: solve these quadratic equations. You can use any method you want. I would recommend using the quadratic formula.